So hey everyone. So this is the first meeting on December 12th, 9 a.m. Pacific time to discuss the KMS work. Yeah, Nish, did y'all want to get started?
Yeah. Yeah, I shared the doc link, right? And then the TLDR is around the Kubernetes 123 release, we decided that there are quite a few GitHub issues related to the KMS plugin in terms of performance improvements and then issues that the users have run into. And we decided that maybe it's an area that we can focus and then try to make improvements and then help graduate that feature from beta to GA. Prior to this doc that I shared, there was another living doc which summarized all of the current drawbacks with the design, and then it focused on specific areas where the improvements can be done. So what we did was we went through that list and then picked some of the areas that we can primarily focus, and then we added those to this particular doc, and then also added possible ways to implement those features, right? And then we've reviewed that briefly between me, Rita, and Mo. So right now we want to open up with all the other contributors and then go over the doc. The three areas that we have added there for focus is performance, observability, and recovery. So we want to go over each of those points and then see the implementation suggestion that we have. See if that's something that we want to do. If we don't want, it will be great if we can brainstorm in this call alternative approaches that we can document and then also maybe elaborate in the follow-up calls. And then as a group, it'll be great if we can decide if these are the areas that we want to do and then also finalize on how we want to do it. Because eventually we want to translate this Google Doc into KEP. And then the KEP deadline for 124 is end of Jan. And then on the last SIG Auth call, Jordan mentioned that it would be great if we can have KEP in the review state in the first week of Jan, so that it gives time for all the SIG Auth leads and chairs to review it and then bless it and then get that merged, right? So this is the first kickoff call for us to go through those docs, and then there have been comments. So let's go over that and discuss that in detail, so that we can take some action items from this call and then see what are the next steps that we want to do. Ideally, it'll be great if we can get a PR up in the first 2 weeks of Jan. If not for all the categories, we can at least try to get some of it for 124. But the long-term goal is to get a KEP for all these features in the next couple of months, so that we only have to work on the implementation, and then that can span across maybe 1 or 2 Kubernetes releases. And yeah, Mo sharing the doc.
Cool. Do we just want to kind of try to go down the doc and look at sort of the comments as they've been made?
Yep.
Let's see, the first. I know this is a relatively recent comment. There's a lot of older comments, but if we're just going literally down the doc, I see Damien's comment about the general area of focus of security, which is fair, I suppose, considering the whole feature.
Do you want me to walk you through the ID?
Yeah, go for
it. So basically, I had when I first learned about KMS, I had this whole idea of it was really security focused. And at the end, I was pretty not shocked, but kind of that it's still not very secure as such. There are still areas of improvements. If we were just to take the vanilla implementation. So for example, the cache, all the DKs that are cached in the API server, we know that they are useful for performance improvements, but at the same time, they might still be accessible if the API server is compromised. So that's one aspect. And the other one is, since there is a way in the cluster to access the KMS, that means that if someone were to have access to the host, then they will also be able to impersonate some kind of like the plugins to also have access to the KMS and either like just decrypt the secret as if they were the plugin, or even worse, like I saw an implementation recently, like for the AWS plugin, that, as far as I know, doesn't allow to change the IAM role. So you just have to like go through with the master one and add the KK to the master role. So that means that you kind of have the master role permission on the KMS if you were to hijack the host, which I don't think is something really good at the end. So I wanted to kind of like see if we could address these kind of issues. And I saw on a couple of talks that some Google folks mentioned TPMs as a solution, and some folks also from Oracle mentioned TE, so trusted execution environment, such as the enclave, to store like most of the sensitive data into one single place and handle like every sensitive operation in this trusted place, basically. And they mentioned in their presentation like that they wanted to introduce some kind of interface for that, which was something I was also looking into, but that didn't go through, I guess, and they wanted to do an announcement, but I didn't see anything about it, so I wanted to see.
Are you referring to the Intel talk a long time ago?
Was it Intel? Maybe it was Intel. I think it was Oracle, but maybe it was Intel, yeah. From like 2019 also.
Yeah, KubeCon, right? Though.
Yeah, exactly.
Yeah. Okay. So I was at that talk, and I asked them afterwards, like, why does any of this matter? Because all the secrets are. So none of this matters in the case of a host compromised, because inside of the API server, every decrypted secret is living in memory. So that attack vector is like basically irrelevant because you cannot guard against it. The only way to guard against is to run the entire API server in a TPM, which we don't support because there's no way to run Go in
that makes sense.
Right. So while I understand that as an attack vector, it's not meaningfully addressable because of the architecture of the Kubernetes API server. Right. In order for it to be performant, it stores every resource in memory. Right. So the working set is always in memory.
But will you still have because you won't have the DEKs in memory, right?
Who cares? You have
because like if all the DEKs are in your trusted environment, then you won't have this issue.
No, because the plain text of the things that the DEKs are protecting are in memory. So the keys don't matter. Right? I don't need the keys because I have the secrets that they're protecting. Right? The API server maintains a full in-memory cache of all of etcd's data decrypted.
Oh, and yeah, so basically what you're mentioning is that the watch cache stores all the secrets decrypted, right?
Yeah, it has to for performance reasons, right?
Oh, that's something I was wondering, and I was also discussing that with Stefan.
Yeah, this is why this is the. Sorry, go ahead. My bad.
Oh no, I just wanted to say that I wasn't really sure that the data in the watch cache was decrypted or not, because at the end of the day, like to me, the API server was just like querying the etcd data. So either it hit the cache or not, like the abstraction was there, and it was just basically doing the transformation, like by decrypting the data.
Yeah, no, it stores them as Go structs, right? Full proper.
Okay.
Because it has to convert them into the version that you want, right? It has to store them as an internal version, and then when you ask for it at like beta 1.
But does that make sense? Because at the end of the day, like we could have the encrypted data in the watch cache.
Yeah, and then you decrypt
instead
it.
Of.
Right, you have to have it decrypted for performance, right? The reason the entire abstraction exists is for performance, right? So yes, you could encrypt it in memory, but I don't know what problem you're solving at that point.
Yeah.
Right, but this is, I'm pretty sure the reason the Intel guys never bothered pushing that further, because I asked them after the talk, purposely after the recording was over, because I didn't want to make them feel bad about their presentation in a live recorded thing, was I get it. You're protecting all these keys, but the keys don't matter because the secrets are in plain text in the memory, right? So the attack vector doesn't make sense, right? So with that, I don't know of any threat model that involves a host compromise where any of the encryption at rest stuff makes any sense at all. Because the way we have this stuff written is specifically, it is a Unix domain socket because it bypasses the authentication problem, right? We are literally saying, if you can connect to the Unix domain socket, you have passed the single authentication check of the system. And thus you are the API server. And the API server is allowed to perform any action over that service.
Yeah, makes sense. And even like when I asked Stefan, he also mentioned that as long as you are on those, like there are other problems that you may encounter, and even like kubectl, you may be able to just leak secret from kubectl.
Yeah, because you can just ask the API server to do the operation.
Yeah, exactly. But one thing I wanted to check with you also, like, what do you think about still like the not the encryption, like storing in a safe place all the information that is needed to contact the KMS, because that's still valuable, like because you might give access to the KMS to an IRM role, as I mentioned, that has more access than just the key that is used in the cluster.
So I think what you're referring to is we have a set of configuration needed for like the KMS and API encryption config just has like, here's the Unix domain socket to connect to and like some cache sizes and some, I think some TTLs, right?
Yeah. And then
I think the other configuration you're referring to is the configuration required by the KMS plugin to bring itself up to actually have
exactly.
domain socket. I'm not sure if we can help you with that, right? Because we are not in the life cycle of the plugin, right? We like basically the API server assumes when it starts up that the Unix domain socket is ready, or you know, if you're using systemd, is using some more fancy mechanism.
Yeah, but I'm wondering if we could include that into like the things that we are giving to the plugins, because at the end of the day, like we are the one that owns like every helper's functions or every interfaces that are given to the plugins. So if we were to provide a set of functions to secure this data, then that could be reused by the plugins.
But
just some idea I'm throwing around.
Yeah, but I mean, that's fair. I guess, doesn't it get you back to the same problem we have with the on-disk based encryption, which is you just move the configuration into our file and now you've made that file a secret, but so was the other file, and they're all both on the host file system. So are you familiar? So I know you work at Red Hat. I don't know if you're familiar with Tang and Clevis. Are you familiar with those two? No. So old coworker of mine at Red Hat, he wrote those tools with some other folks. But they basically, Red Hat calls this network bound encryption, which is the idea that you have encrypted data on like disk or whatever, and as long as you can reach a particular network service, you can over like plain text, it doesn't require any encryption on that connection. You can basically finish the cryptographic operation required to do the decryption. I think those types of like I can show you, like because I did you'll see this stuff like long ago. Right, so this KMS plugin, right? Like the idea of it was basically, I will get the key encryption key decrypted as long as I can reach this Tang server.
Okay.
The idea is that you're sort of offloading some of that. We're kind of getting off the path of maybe what we should be discussing, but yeah, I don't know though if we're in a position to answer this question well, right? Like, you know, certainly like, you know, if we're thinking about like AKF or others, you know, or the cloud providers, right? They can use their own infra to help with the bootstrapping problem, right? To securely deliver whatever metadata or credentials to the host and protect it as best as they can.
Yeah, sounds good.
Foundationally, though, this API is limited by the construct of we are asking it to do the encryption and decryption, right? But the decryption is allowed, it's authorized, right? So I might just leave this as a comment for now so we can keep sort of thinking about it. But I mean, I guess I don't disagree with security as a thing because it should be like the entire feature.
But I think you are very right that such should also be deferred to the plugin at some point. Like if they want more security on that side, then it's up to the plugin. There is not much we can do.
The aspects of security that I feel like we could try, and this is something I wanted to ask Anish and Rita and see what they felt like, is I know a while back, Rita, you had mentioned that we could help with the problem associated with like if you accidentally delete the key in your cloud provider by having some concept of a lease, so that way we can indicate to the cloud provider like where a key is being used and sort of why, and they could prevent that from being deleted very easily. I'd wondered as like an extension of that, could we expand the API to be more about the life cycle of keys altogether, right? So instead of it being purely like, hey, tell me what key to use and I'll hold a lease on it until I'm not like until I'm dead or whatever. It could be, give me the capability of creating keys, and when I create them, I obviously have a lease on it, but also let me create more than one, so that way I can do automatic rotation over time. Right? That's sort of one aspect of this that I feel like the KMS plugin is sort of in a better position than others to sort of help with, which is key rotation. Because as far as I understand right now, today, and this was vaguely mentioned in the original doc by Alex, right, where he was like, could we like move some of these rotation constructs into like the Kubernetes API, so that way not every single provider has to rewrite this from scratch? Which is fair. It's really hard to make a sensible API out of some of this stuff from a Kubernetes perspective because it's so dependent on how you deployed your host and how they're provisioned, right? Because basically, if you want to do rotation today, you would update the API configuration to have a new item at the end, which is the new KMS configuration, roll that out, then flip it so the old one is the read configuration and the new one is the write configuration, and then do a full storage migration, right? Those steps, while easy to say out loud, require a lot of work. I know this because I wrote this for OpenShift, or I wrote parts of it, and Stefan like fixed a lot of my mess. But it's there, right? It does the dance, right? And of course, the dance was extra hard in OpenShift because it's a self-hosted system, right? But the problem doesn't go away just because you're not self-hosted. It's just maybe slightly easier. So I was wondering.
Yeah, just to go back to your original topic of like tracking the life cycle of the key, I think like that's would be very valuable. And yeah, the main way it could be valuable is first like for rotation, because then you can know when the like the KMS is creating new KK, which is something that you don't know yet. And so if you want to start some key rotation on the side, then that's not possible today because you don't have this awareness. And also help like the users, as you mentioned, track down like what are the keys that are still used. And yeah, because currently like there is no way for that. Like I don't have any awareness on where are the key used. Like if a new key version is created, for example, in GCP, then they don't know if like version 3 is still used, or like if they can delete it or whatever. Like they have no awareness at all in this process.
So today for every mutation, we do a new key encryption, or sorry, new data encryption key, right? Or sorry,
Yep.
So were you referring to key encryption key, like the root key?
Yeah, I was referring to key encryption key, not
Okay.
data encryption key.
So that key is abstracted in the KMS, right? So
Yeah.
Kubernetes is completely unaware of it. I think you might be saying, or was the thought or request that maybe that should be more observable through?
Yeah, exactly.
Now?
Exactly.
I think a fair ask.
Yeah, I
Because
think that's where if
currently, I
you
don't think we have. Yeah, go ahead, thanks.
No, I was going to say, like, that's why, like, down the proposal, like, we have this one where the KMS plugin actually provides some kind of metadata about the key it's using, right? So, like, the key ID and all that. Even though it doesn't make sense to the API server, it's something that it can still send it back to the KMS plugin on next encrypt or decrypt so that the KMS plugin can use that information rather than having to find it every single time.
May I suggest something, since we're like almost halfway in the call? As you can see, there's phase 1 and phase 2. There's a lot to be discussed. I was wondering if we can focus on phase 1, which we kind of start talking about, recovery, right? We're beginning to talk about that and the key rotation stuff. So I wonder if we could maybe jump down to phase 1 just to help with facilitate the conversation, so that maybe by in this call or future calls, we would know like what we need to do for phase 1.
Okay, so who wants to talk about observability?
So yeah, I mean, in terms of observability, like the main intent for adding that is today the KMS plugin is not aware on the KMS plugin is not aware of which secret it's encrypting or decrypting, like in terms of just metadata. And
Is there a 5-year-old?
Okay, sorry about that. So yeah, the KMS plugin today is not aware of which secret it's encrypting, decrypting. And then on the path back, again, the API server does not know which key or what the KMS plugin used to encrypt or decrypt. So that is one thing. And then apart from that, there is actually no way for us today to have a trail where we say like this particular request originated from API server, this came to the KMS plugin. And then if we want to audit that on the external KMS store like Key Vault or Secrets Manager, then there is no way for us to actually have one trail with like no kind of ID or anything that we have today. So I think in terms of observability, the two things that we proposed was one is audit ID, so that it's a UID generated for every encrypt decrypt operation. So it's a unique ID for each operation. So it's one for encrypt, a different one for decrypt. The audit ID is one thing. And then also in terms of the observability part, just so that the KMS plugin and the API server are more aware of what operations they're performing, the KMS plugin will get just the secret name. Like, so it already gets the payload today, and then it's basically in the dark, but it'll probably get a secret name or some other metadata that it can use for logging purposes, which makes it easier for debugging. And then the second one is when the KMS plugin is done with the encrypt or the decrypt operation, it would send additional metadata back to the API server, which is, it says, I used this particular encryption key version, like, or any other metadata that it thinks is safe to be shared with the API server, so that the API server has it. And then when it makes the next encrypt or decrypt call, it can tell actually, I think
It's going to be hard for Anish to get any work done today. It's going to have to go outside.
So when it actually makes the decrypt call, the KMS plugin, the API server can say, hey, look, this is what you encrypted it with, the key KEK version. Maybe this is useful to you, but this is what I'm giving to you. And then at that point, if the KMS plugin is maintaining some kind of cache where it says this key is deleted and all that, it can avoid making these external API calls, and then it can make a decision from there. So in terms of observability, it's trying to provide more information to the Kube API server and also the KMS plugin, and then also providing a trail where we can easily audit in the external KMS stores. Yes. No.
So I'm looking at this, some obvious sort of concerns, like for one with audit ID, that is a user controlled string. If you set that header on a request, the API server will pass it through. It will not generate its own, which is to me a bug, but it is a long existing bug that exists. So maybe you mean this is some other kind of audit ID, some new one.
Yeah, that's what I meant. So like for every operation, it generates a unique ID, like just something before it does the operation rather than the user passing this. And then like there is some kind of trail, like so we can just filter logs on all the whole path, like as we trace it using that particular ID. And then also like when the KMS plugin gets that ID, it can use that to log into the KMS store, so that like if we go into the KMS store and like look at the logs, then we can use that audit ID to correlate that, oh, this encrypt operation was for this Kubernetes secret, and then it came from this particular cluster. Like, for instance, if they're using the same KMS store across multiple clusters too.
Are you concerned that users may be because they know audit ID, that they may use it for other purpose?
I don't think I understood the question really.
Well, you said user ID, sorry, audit ID is user generated, right?
So the
What's the
term audit
concern
ID was confusing to me because in Kubernetes, the Kubernetes audit stack contains an ID for every request, and a user can manipulate that header to be whatever they want. And if it's not set, the API server sets it itself. And I thought this was that same value. Basically, what this was trying to do is correlate all the way from the user's request down all the way to all the KMS, right? Which to me would be more useful than a particular encryption operation caused all of this to happen. To me, it'd be much more useful to say a particular user request caused these n encryption operations to happen within the KMS, right? We just don't have like yeah, it's just not tracked like that today in sort of maybe a good way, or like, you know, you could, because it really should be the audit ID, right? You should be able to look at the Kubernetes audit log, say Mo made a request to create this config map or secret maybe, and here's like the encryption that happened because of that. You should be able to trace all that, in my opinion. So if we can make that happen somehow, that'd be nice, but it cannot be driven by a user-controlled string. So that sounds awful. Now, that might be as simple as saying that we need to come up with a better way to control this this field, right? We can't just let any user set this header. It needs to be some level of checks in place. The other bit, I think it's a little bit unclear to me in some of these structs what the actual data would be. So it'd be helpful to me to just have like some just exploded examples of like, here's maybe one example, and if there's a few variations, just throw them in just so I understand. Like thinking through, like, for example, today, you know, we only get the ciphered response. We don't get this one, right? Are we expecting the API server to store this? Or it has to, right, somehow, because it's supposed to return it back. So what that immediately tells me is we're proposing a storage schema change, which immediately makes it so that we cannot make, we can only teach the API server how to do this in 1.24. We can't make it start doing it, because if you made it start doing it, you can't downgrade, because it would start doing it, write data in a format that the old API server no longer understands, and you can no longer downgrade, which is bad. Maybe it would be okay if this was an alpha API, because we'd be like, don't do it. It's alpha, but it's a beta.
Please
API.
don't remind me.
So there's some issues there, right? If you're proposing any schema change, we have to have some undo path. And
That's a good point. Yeah.
maybe we can work around that by starting, like, part of me thinks that this whole thing should be an alpha API, just a new one. Like, we just leave the beta one alone and start with an alpha one and say, cool, we're gonna break all sorts of stuff. And we're
Another POS security.
yes, basically.
Oh God.
But like, otherwise, every time we come up with a good idea for a schema change, right? Like, I mean, okay, maybe we have to come up with a proper structured schema to store this on disk that is like a Kubernetes API on its own that can express proper additions of new data without requiring the whole thing to be thrown away. And maybe that's the first step, right? Maybe that's the step we do in 124 is teach the API server about a new properly structured, either binary or human readable format that can be expanded over time. So that way we could add stuff to it and have some hope that if you downgrade that it still can read the data back, right? But I would suspect, right, that if you were using KMS already and you upgraded and you got the newer features or whatever, that if you needed to downgrade, it wouldn't result in data loss because you couldn't decrypt half of your system anymore, or basically all of it, probably.
Especially if you want to use it for like recovery purpose or something, that would be pretty bad.
Yeah, and one of the things that was outlined by Alex in that original doc was that you can't do anything with this data without the API server. Like or like it's code, right? Like you can't process it with an external tool because it's basically a made up format that we made and we wrote it into etcd, and now we're like, cool. It's like you're locked into using an API server. That's like, that seems sketch. Because at least beforehand, the proto was technically unmarshable. The JSON was definitely unmarshable.
Mm-hmm.
With this, it's basically like, nah, you gotta use our stuff. So there was some, I forget the names, but there was some specific industry standard that Alex had pointed us out, like, hey, maybe we should like store it like this, so that way you could realistically write a new tool, or realistically write or use an existing tool that wasn't the API server. Yeah, so those are sort of just my initial thoughts. Christoph, Damien, did you all have any?
Yeah, I have a few questions as well, because there are a few aspects that I'm not sure I understand properly. So what is exactly the data that we are trying to log, like from the KMS plugin side? Like what's the actual information that we are looking for here?
It can be anything.
I mean, as you know today, right, it's really hard to tell like which, as Mo was mentioning, right, which request actually triggered the encryption and decryption. And even within the log, sometimes it's really hard to debug, like, is this actually, like, when did the decryption actually happen for this particular request? Because it could have been cached, right?
I see. So
yeah.
you don't really care about the actual data, so even the plain text or like the cipher or whatever, you don't really care about it. You just care about where the request went through, right?
The sequence of the operations. Yeah. So
the idea, if I understand correctly, is that you will want to kind of propagate an audit ID from the actual query to the API server down to the actual query to the KMS plugin, right?
Yeah, as you can see from the first number one bullet point, it says Kube API server, KMS plugin, and then the actual KMS. Yeah.
Okay. Yeah, sounds fine.
And I think to this, what I would add is, when I see Kube API server, what I also think of is, right, like this is what I think of, right? because I don't want to look through the poorly written logs within the API server. I want to look at the proper structured, fully supported feature, which is Kubernetes audit logs, and look at that one and then correlate with KMS and be like, cool, right? And I want it to be able to be done in a way that a machine can do it. So that way, like when I have to go write this code, or Anish or Rita has to go write this code into their products, it just works. We don't need to like invent some craziness. It just is a thing we can do. So, and that's where my hesitation came about audit ideas. Like I don't want a user to be able to, send a 3 megabyte audit ID as their thing, watch my KMS crash and burn on fire. As it's like, I don't know what to do with this. And then
your idea, Mo, if I understand it correctly, is just to like inject a new ID inside of the audit log that are already existing, right?
we could do that, but then we would have to do something with the Kubernetes audit infrastructure to make it have that audit ID.
Yeah.
So we could go grovel to the other SIG Auth leads that manage Kubernetes audit and be like, can I have a new field? And they'll say no, probably, because they're like, why do you need a new field when I have an existing field?
And we're supposed to enhance audit, remember? For 124 anyway, so might as well.
Yeah, so there's that. There's the freeform audit annotations field that could be a thing, but it seems to me audit annotations is supposed to be reserved for like things that are not part of core and like want to add additional data through the stack.
Yeah, but
Like, doesn't make sense.
Why in the first place, like, couldn't we add just fieldstudio audit logs? Like, there are still logs in the end, and if we need more information to correlate them to other logs, then to me that sounds like a plausible thing studio.
Yeah, no, it's just weird to have more than one ID field within a particular. Right. That's the weirdness. So I think the request would be, we'll figure out how to use the existing one, which then we'll turn around and be like, all right, we have to make it trusted. So how do you make it trusted?
Just to summarize, I think sounds like we need to take some time to think about how to leverage the existing audit ID, and if not, then because we're adding a new one, there could be backward compatibility issues. So then do we want to create a new API? An alpha API, right?
So I think with audit ID, we don't have backward compatibility issues, right? It's only with the data written from KMS plugin. If that needs to be stored, then we might need a new API, or we have to see how we can do storage for the new field.
Even for audit ID, why is that?
Not for audit ID. So I think for audit ID, it would be, I'm hand waving, maybe there's some feature flag or whatever. Whenever the feature flag is set, you could have audit IDs emit extra fields with new data. Totally fine, totally backwards compatible, should not cause any harm. The backwards incompatibility is associated with if we are sending extra data to the KMS or receiving extra data from the KMS, in those, if any of those operations causes us to have to change our schema on disk to store it, which I assume we have to, because otherwise, why would we bother? If we're not storing it, we don't have it to send back. Then we have to have a story around how does that work, right? And if the story is going to be, what happened to our comments disappear? Were they addressed? I'm just sorry.
Somebody did something.
Okay, I'm assuming it was on purpose.
It wasn't me.
It wasn't on me. I understand. Damon, were you addressing, were you hitting checkboxes on some of your comments?
Oh yeah.
Okay, I was just like, I was
addressing my comment. No worries.
It's fine.
When you do that, it goes away. Yeah.
No, I was just removing them because they weren't meaningful anymore, because you kind of answered most of them.
Yeah. So if we're gonna go through the process of doing schema changes, it's going to be basically impossible if we're saying that this is going to change the existing API, and thus every time we need to do a schema change, we need to have one release of rollout, where we just roll out the ability to parse the schema, and then the next release we can actually do any real work using the schema that we just spent that last 3 months waiting to be funneled out. That seems really impractical. At that point, it seems better to start with an alpha API where we can say there is no stability of the schema. This is an alpha API. We're working through it, and build in either the extensibility or whatever we need to be able to promote it to a beta API without having to worry, or just say that like we will not graduate it from alpha until we're like really done with the schema.
I mean, in addition to this KEK version, are there other new things you think that could impact this decision?
I mean, so
Well, the TTL thing, or
yeah, so if there's anything like a TTL that's being sent back, maybe I could also imagine, like if we decide to do anything with rotation, right, there might be extra metadata that we need to include from both sides of the conversation.
Yeah,
At the bare minimum, if we had a structured config, we could maybe like very, very carefully set up things so that like as we add new data, we don't change the meaning of existing data. We leave it alone, and then we just continue to keep adding.
I was going to say the same thing too. So like, I mean, as we go through this, like, I mean, observability and then recoverability, like, and then if we see there are.
Good Lord. I'm sorry, Anish, you're going to have a bad day, dude.
So if we have new fields that we think will actually improve the user experience that we have today, like, and then as we keeping an aggregate of things that we need, if there are significant number of fields that we want to add and store, and then I think like basically we can say we're leaning towards a new API. But if it's only like for 1 or 2 fields after we go through the entire proposal, then we can still see if that's something that we can do with the existing API rather than having to revamp the whole thing.
I mean, I guess the other thing is like, if you didn't have it, like for backward compatibility, are there reasonable defaults that we can use?
For what, I guess,
like say for TTL, maybe there's like reasonable defaults, but for KEK versions, I don't know, like you can't do, there's no default, right?
Right, I mean, at that point, the API server just sends an empty string, and then basically KMS plugins have to handle the scenario where it's empty,
right,
not rely on it, which is today's behavior. And it's like an additional improvement to say, oh, I have a KEK, so let me do something with it. So like that'll be like an added one, but they have to support compatibility basically.
Right. So okay, let me make a note of this. Okay, yeah.
I think Christoph wanted to say something before.
Oh, I wanted to add several times something, but then the conversation moved on. So basically I agree with Mo that we can't rely on anything given from the client. So sometimes it might be quite useful to have this information in case it was a good user that has no bad intentions, otherwise it can go really bad. Also, I think it's the right way to go with an alpha API version, because then we are more free to experiment, try something out, and don't bother all too much. And I mean, don't hate the player, hate the game, right? So I think that that's the attitude. And once we feel like, oh, at the end it's just 2 fields, we still can kind of backpedal and try to add it to some existing API. So it would give us more freedom.
Yeah, I suppose if we did build this out as an alpha API, if we came to the conclusion when we were done with it that, oh, it's not actually that much different from the beta API, let's just fix the beta API and delete the alpha, that would be fine. I don't think that's like breaking anything. It's more of if it's an alpha API and you try, there is basically no accidental way for you to use the alpha API, right? Like, and also there's no way for you to use it and say that you're in a supported configuration of any sense, right? That's a pretty significant like guardrail to say that, yeah, like the reason we don't support downgrades right now is because we're not done. Like, we're not in the state that we can reasonably support you doing that. It's much hard. Like like the reality is the encryption at rest API has been in beta for so many years now, effectively, that it is everyone, right? Like it's just is, right? Like it is widely deployed, sadly, in its current state, at least in the cloud provider environments. And to be fair, it had, it's been an order of less than a week since someone last asked me about it, and like they're like, hey, I need to deploy encryption at rest, and the on disk stuff seems dumb. So like, how do I use a KMS? It's like, oh, you want to know how to use a KMS? You're gonna be sad. So I mean, it is a thing that people want to use, and I don't want to. I mean, I'd be willing to ask like Jordan and stuff and others and Clayton from like an API perspective, if we added some kind of feature flag to indicate that indicated that you were basically opting into alpha style features and you were giving up backwards compatibility. That's effectively a different way of doing an alpha API. The hesitation I have with that is that would require us probably to change the code in place. And it's very hard to guarantee that you have not subtly changed the behavior of the code. Right? But I mean, I remember recently someone downstream got broken by a change to the HPA controller or some other controller because they had some new logic that was feature gated, but some of it slightly leaked into the non-feature gated part and it subtly broke them downstream. Right? So it's very hard to make sure that that doesn't happen. And to be fair, I have the same concerns with the kubectl client go proxy thing that I've been talking about in the past, like a while back, right? That involves changing an existing feature that is GA'd to have more functionality. And I don't know how to do that in a good way without having any risk. We still got a few more minutes that we want to keep kind of going down.
Yeah, I think recoverability is still smaller topic. The idea is
just before that, I had one topic. If we want to stay on observability, I just wanted to add one thing. I had decided that currently it's a bit annoying that like we have all these plugins and we don't have like common metrics between them. So there is no way to actually like create generic alerts. So if you need to support multiple plugins, then you have no ways to actually create alerts for like just one alert for all of them. So one of the idea I had was to add metrics as a library, like add a couple of metrics that we could share between the plugins and provide that in one of the library that currently exists, so that the plugins can directly register the new metrics and we can leverage that afterward.
So if I could, let me try to echo back what I think I heard is that there's a lot of flexibility within this API, but there might be a set of best practices, metrics maybe being one of them. And I think the ask is, could we provide some foundational library code that one could basically shim into and add their own bits, but similar to like maybe secret CSI driver providing an abstraction layer for getting secrets from CSI, we might be able to provide not like necessarily a whole scale sub project, but just a set of libraries, or maybe a library, which is basically like, here's a go function for encryption, here's a go function for decryption, do whatever you want. But the rest of the code looks basically exactly the same across all providers because it's just a KMS API. And obviously you're not required to use it. It's just that it'd be cool if everyone did. So that way the on-ramp is easier.
That's exactly what I was referring to. And the goal would be to only like provide a function that would return the metric that we would say are like best practices and like covers most of the observability use cases that we have for alerts, for example. So for example, we want to count the number of decrypts so that we have a rate of decrypts, we have a rate of encrypted, stuff like that, so that we have like more observability on the actual number of queries that are made to the KMS. And then it's up to the plugin to actually like register those metrics and expose them.
It's a great
So
idea.
I suspect like things like, for example, latency on requests and stuff. I feel like such a library could do that by default, right? Obviously, it's still up to
Yeah,
you
exactly.
to expose it, but we would basically be recording it all the time, right? Like, so encryption
Yeah.
took 10 milliseconds. Cool. I'm storing it in my Prometheus structure. It's your choice to expose that Prometheus structure in whatever way you have consumers that can consume it, but it's all there. So yeah, all that sounds great to me. And to be fair, lines up really well with what we've done with like client go credential plugins, right? There is a samples library that includes a fully functioning one that you can plug into and change your stuff, right? So I think that's well within what we've done in the past. And in retrospectively, it sounds like a mistake that doesn't already exist, right? Because that
Yeah, we'll
means
try to
that,
look into that and bring like actual metrics to the next meeting and actual like use cases.
Mo, can you add a link to what you're referring to?
the sample client.
The client go credential metric stuff. Yeah.
Oh, sorry. So it's not purely, that one's not metrics. That one is a full Go library for you to build your entire plugin with basically the correct set of best practices, right? So Damon was pointing out just metrics as one best practice. I was pointing out that like 90% of this looks exactly the same, right? Like the only thing that's different is my encrypt call calls AKS's API versus GKE's API. Sure.
So maybe like a reference implementation.
Yeah, basically, exactly. A reference implementation with best practices around things like metrics and other things. So that way, if you want to write one, the task is much smaller.
I get it. Yeah, and the metrics library will be part of that.
Yeah, and you know, we can make it nice and pluggable in case you didn't want to use it or whatever. But I honestly, I can't imagine someone saying, no, I don't want metrics on like when my KMS plugin is being really slow.
Yeah.
Cool. Yeah, so that sounds all good.
So we only have 4 minutes. So I was going to say, like, do we talk about action items, at least based on today's discussion? What we want to do next?
Well, like I have questions on like right now we're lumping observability and recovery like as phase one. But for a KEP, do we want to just focus on observability?
So that was going to be one of my questions. So like for the KEP, do we want to do it as each individual KEP, or do we just have one KEP where we keep adding? I don't think that'll work. Like we can't start a KEP with observability and add recovery to the same KEP. So maybe we have to have each of it as different KEPs. But if we want to have individual KEPs, then I think like what you said makes perfect sense. Like we start off with observability, like at least we can hammer on that.
I prefer separating them just for the ease of discussing and moving forward. Otherwise, we just end up like talking on the PR over and over. Yeah. It happens.
If I can just give my opinion on that. To me, both topics are similar, and the answer is observability, because for recovery, I don't think like the mechanism that was proposed, like to have a way to force delete the secrets or like any resource is the right solution. And the reason for that is that if you are users, you want to know like what are the secrets that were deleted, because you may want to recreate them in the case they are irrecoverable. And to me, like the best vector for this kind of information and to alarm the user as fast as possible is to have metrics and then alerts to tell them, hey, there are unrecoverable objects in your cluster that needs to be fixed. And then there are the list of the actual secrets, for example, that they need to delete and recreate. And to me, that's a manual process that we don't want to automate, because the users need to be aware that some changes need to be made.
Yeah, so that's why we added the second one, right? So initially we thought about one, but we don't want to automatically delete. So that's why we said the second one is the more reliable approach, where the user forces the delete. And when they do a force flag. So today, if you do so sorry. So today, if the user tries to delete and if it's not recoverable, basically they cannot delete it. So that's why there's a proposal that maybe we can add a force flag where the user says, okay, now I'm not able to list my secrets because of this one unrecoverable secret. So kubectl delete secret force, at which point the API server says, oh, this is force. I'm not even going to try and decrypt it. I'm just going to go and remove it from etcd.
Yeah, so there's a bunch of problems in this one, right? So one is the lack, having one secret being undecryptable, causing all lists to fail is really catastrophic, right? It basically destroys the API server, right? It just becomes unusable. Okay, that's one problem. The other thing is any of these force delete mechanisms explicitly bypass Kubernetes lifecycle management, right? So they bypass finalizers and stuff, right? Which then breaks the Kubernetes API in some ways, right? So if I understood correctly from the last time we talked about it in SIG Auth was the gist I got was this is not a problem that we can meaningfully handle. It is basically a storage level problem that the Kubernetes API cannot meaningfully handle, right? So it might be that the existing behavior is fine, which is to just break and stay broken until manually corrected. And certainly we can work on trying to make it easier to understand what is broken and thus allow admins to go remediate it manually. I think my desire here would be to try to come up with ways to, similar to what Rita had said about having leases and stuff on keys, to basically make it like incredibly hard to get into situations where you cannot decrypt data, because like once you do get into that state, the Kubernetes API no longer works. Right, the semantics of the API have been broken. Either you have to be able to ask for partial lists, which is bad because now you don't have a full list. So the semantics of list and watch don't make sense. Or you have to delete stuff and skip Kubernetes lifecycle, which also doesn't make sense because then you're breaking the Kubernetes API in a different way.
Yeah, to add my 2 cents on that, I think you raised a good point, and the problem here is that it might be better to stay in a broken state, because even if we were to force delete all the unrecoverable objects, we have to consider that some other like users may not only encrypt secrets, but other information, such as, like, for example, in OpenShift, we're encrypting routes. So basically, like DNS behind services, we're also encrypting OAuth tokens. So if we were to force delete this kind of information, the cluster will be in a worse state than if the list was failing, because like you would basically break all the thing that these basically everything that was relying on this data that was deleted will be broken, whereas like in the first place you would have just the list that was broken. To me, it's worse to delete.
Yeah, the problem actually comes, I think, when you have like a managed offering, right? So the only way today to recover, like where make your list calls work again, is you have to go into etcd and delete it. And then if you're running on a cloud provider, then there's no way you can actually do that. Which means either cloud providers are forced to have an API to do it, or like it only works through support tickets. Until then, like the list is just broken, right?
It is a fair point, right? etcd access is basically a no-no. Like I know, it's obviously like possible in kubeadm clusters and OpenShift, right? You can just export
everything that is managed
and poke away at it.
Yeah.
Assuming the cluster is functional enough to let you do that, obviously. I've broken many a self-hosted cluster before. Yeah, we're a little bit over time, so I think we can pause here, and then Rita for next steps, which is a good call out.
And one more thing, what when we would so another thing that might be good to have manual involvement from people. Just imagine we would somehow force delete certain entries and have a functioning cluster again. And what if I could provoke this and push the cluster in a state which would make it open to attacks from me? So I could somehow get rid of some of the keys. Then I would know that some secrets would be deleted because they're not usable. Then somehow the cluster changes the state, and this could be maybe also an attack vector, right?
Yeah, any automatic delete does give me concerns, right? Because if you can coerce the automatic delete, then yeah, you could cause the system to just go around shooting itself up.
But it's also like if you imagine you're an SRE in the middle of the night, you get the wake up call, you look it up and you're okay, I need to delete those 4 or 5 things and then I can go to sleep, or it can go bad, right? So it's not like in the middle of the day where you're freshly recovered and you can think rationally easily. So humans are also like a potential issue.
Since there's much to be discussed for recovery, let's pin it for next time. And then let's continue that all the discussions within the doc. So for next steps, sounds like we want to move forward with observability enhancements, right?
Yeah, my 2 cents is I think it's fine to have many smaller keps so we don't try to boil the ocean and never get anywhere. The only high level concern I have about all of that is I just want to make sure that the end state that we eventually reach is the state that we want it to be in, and not like a series of half states that never coalesced into a larger picture. But I have faith that if we're also all meeting and discussing and making progress together, I think we'll be fine there too. But yeah, trying to write a KEP and then have it answer every single KMS problem probably is not going to work.
No.
And also, if I understand it correctly, you can't really change the scope of a KEP once you've written it like very broadly. It makes it very hard to track, right? Because what's alpha,
Right.
then what's beta? You just added a bunch of new requirements. Now, did your beta API become alpha? That doesn't make any sense.
And even like we have a short timeline, we need to be like mostly done by the beginning
Yeah.
of January. And if we have like one big KEP, that will be most
No.
likely impossible.
Yeah.
All right, I got to drop. If we want to continue some discussion on Slack, we totally can.
Thank you, everybody.
Thanks,
Yes,
everyone.
Great discussion.
Thank you.
Thank
Yeah.
you,
Yeah,
bye.
definitely. Bye.